1, 2, 3, got a task into the stores. Kick open those doors. I'm a kid with the complex comprehension. Superpowered mind, hysterical punchlines. Protecting the world from alien abductions. This is the main tune. Dan Druff the cartoon. Wait, this isn't a cartoon. Welcome everybody to the Druff Show. Tonight we have a very special treat for you geeks out there. Yeah, I'm talking to you, Sheehan. Dan Druff, Physics Edition. Tonight we'll be exploring various concepts from kinematics to inelastic collision. Now some teachers out there, Sheehan, think they have taught you the right way. Well, they haven't. They're all wrong. I'm going to show you the real way, the Dan Druff way. Let's get started with some force diagramming. I'll turn it over to my assistant and he will show you those ropes.
Me and Mr. Putty are going to help you with force diagrams. First, force of friction always opposes motion. Force of weight is your mass times the gravity. Normal force is always perpendicular to the surface. Force applied, I already did that one, is when a force is applied to one thing to another. And then there's some more that you need to know, like force of tension and force of contact, but we don't really need them for this example. As seen here, there is a small child being pushed by an even smaller child. In the force diagram, the force of friction directly opposes the force applied in the x direction, and in the y direction we have the normal force and the force of weight, which are equal to each other because he's neither moving down nor up. The force applied must overcome the force of friction, or else this small child will not move. The force applied by the small child is 5 newtons, and the mu is equal to 0.7. So our equation is the force of friction equals mu times Fn, while Fn is equal to Fw, which then equals mass times gravity. So if we put in our givens, we get 50 times 10, which equals 500 newtons. And to find the force of friction, we would multiply that by mu, which would give us 350 newtons, which is obviously greater than the weakling's 5 newtons. And so that weakling is actually pushed back because he's such a small, insignificant little sissy.
Poor James, it's too bad he couldn't push that little boy. Well, let's get a move on and go to projectile motion.
I wonder what the max height is. Let's go to Dan Druff's assistant.
Projectile motion. We given the fader, and the initial speed, which is 8.2 meters per second, and we try to solve for max height, the height that's maximum. And what we do here, we find Vx, Vy. Vx equals V cos theta, which comes out to 2.8 meters per second. And then we find Vy, which Vy equal V sine theta, which comes out to Vy equals 7.7 meters per second. How? Okay, I choose this kinematic formula, and we given the delta y equals 0 because it started 0 and it ended 0 at the end of the loop. And the Vyi equals 7.7, which we already found, and the acceleration due to gravity, negative 10 meters per second squared. Now, even though we're only looking for half the loop, we're going to do the whole loop to find a time. So we're looking for time equal question mark. Okay, delta y equals 0, cancel out. And then what we do is we get the variable alone. We need to find t over here equal negative 2 Vyi divided by a. Plug in the numbers, plug in the givens for the variables, and it comes out 1.54 seconds. But that's for the whole loop. We only need the half the loop where the max height at, and so equals 0.77 seconds, which is where the ball reaches max height. Game over. Okay, now we have enough givens to do another equation, another kinematic equation. Then triangle y equal 1/2 vi plus vf times delta t. Vi equals 7.7, which is how fast he threw it upward. And now vf equals 0 at the top of the height. It's not going nowhere. Alright? And delta t we found equal 0.77. So we put in the given, do the math, because I'm Asian, and come out to 2.96 meters in the air.
Man, I have a really good arm. Anyway, all of this physics talk is really bringing me back to my high school days, where I first learned about Newton's 3 laws, with Mr. Sheehan. Hey class, I'm your teacher, Mr. Sheehan. Let's get started right away with today's lesson. Newton's laws. There are 3 of them. Oh geez. Well, there's 3 of them. First law, objects in motion stay in motion until acted upon. Objects at rest stay at rest until acted upon. Newton's law number 2. Oh. Noviello! Come here real quick. Now I remember. Newton's second law is force equals mass times acceleration. My knee! My knee! I'm sorry, class. I heard this in my earlier days riding with the bulls. Can't believe you guys believe that. I got kicked off a dock by a dog. Yeah, that and snowboarding. I forgot I was rock climbing. Ridiculous. Man, I really needed to shave, huh? Anyway, Newton's third law is every action has an opposite and equal reaction force. Hey, don't let up at the door! Man, that class was so dreadful. Made me want to jump off a cliff. That brings us to our next topic, free falling! Free falling! Yeah, I'm free! Free falling!
Well, we got some free falling right here, and this boy's jumping off a building, a skyscraper. And what we've got is delta y equals VIT plus 1/2 AT squared. And what we're looking for here is how far down he's going after 3 seconds. And now the givens, VI equals 0 meters per second because he has no speed as soon as he jumps off. He's just going 0 meters per second. The time is 3 seconds because that's how long we're looking for and how far down he is after 3 seconds. And the acceleration is negative 10 meters per second squared because that's the acceleration due to gravity. Alright, here we've got the equation for free falling. VIT cancels out because VI is equal to 0. And we'll have to 1/2 AT squared, or 1/2 times negative 10 times 3 squared, which gives you 45 meters downward. But it's not really accurate because gravity is actually 9.8 meters per second. Who cares?
Man, Dan Druff's life was full of so many tragic events, and just terrible things happened to him. All of those events inspired him to keep on keeping on with his physics, which leads us to our last problem, inelastic collision, which is my favorite, but it's just so sad. Poor little Bill tried crossing the just watch it.
Inelastic collisions. To solve, use the inelastic collision equation, which is the m1 times v1 plus m2 times v2 equals m1 plus m2 times v prime. Our givens, the car weighs 2200 kilograms and is travelling at a speed of 12 meters per second. The random child is 81 kilograms and is travelling at a speed of 0 meters per second. We are trying to find v prime, or the speed that they went at after the collision. Because this boy is not moving, this part of the equation cancels out, and the next step is to isolate v prime, which is done right here. And then the next step after that is to input the givens for M1, V1, M1 and V2, M2, which gives you V prime equals 11.57 meters per second, which means that these two, because it is an inelastic collision, travel together at 11.57 meters per second. Let's watch the little chubby boy get hit by a car.
I must warn you, no one was hurt in the making of this video. Except for that poor little kid, Bill. Aww. But seriously, do not reenact or attempt any of these stunts. They were done by Sheehan's honors physics students, which you cannot compete to get on that level! Thank you everybody for viewing the Dan Druff Show Physics Edition. I hope you enjoyed it. Thank you and good night!
Oh, I'm a gummy bear. Yes, I'm a gummy bear. Oh, I'm a yummy, tummy, funny, lucky gummy bear. I'm a jelly bear. Yes, I'm a gummy bear. Oh, I'm a moving, grooving, jamming, singing gummy bear. Oh, yeah. Gummy, 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 gummy bear. Gummy, 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 gummy bear. Oh, I'm a gummy bear. Yes, I'm a gummy bear. Oh, I'm a yummy, tummy, funny.
Thank you everybody for visiting. Oh, why did I say visiting? I say.
Let's say there's the equation for free falling, and what we've got here is triangle y equals VRT plus 1/2 AT squared, and VI equals 0 meters per second because he just fallen on, you know what I mean. And at time, we're looking for how far down he's gone, how fast he's going. Wait, what am I looking for? How far down he is?
How far down? Man, I have a really good. I messed that one up. I'm sorry, class. I heard this in my earlier days when I was riding with the bulls. I can't believe you guys believe that. It's ridiculous. I just lost my beard mic and just fell off. I had to push it back.
Surprising.
My apologies, class. I heard this back in the day when I was riding with the bulls. Oh my god. My apologies, class. My apologies. I heard that back in the day when I was riding with the bulls. Oh my god.
Go.